Imagine a future where humans live on Mars, building a new world on a planet over 54 million kilometers away. But for that vision to become reality, we face a huge question: can we actually grow food on Mars? Today, we're diving into the groundbreaking science behind farming on Mars. We'll look at the innovative approaches scientists are exploring to turn Mars into a sustainable home for humanity, starting with the basics and moving all the way to cutting-edge solutions in bioengineering. Let's explore the quest to farm on Mars and see how we might feed future Martians. Living on Mars is about more than just landing there. For any Mars colony to survive long-term, there has to be a reliable food source. Relying on supply missions from Earth just isn't practical. Every resupply mission would take months, and the cost of transporting food to Mars would be enormous. So for Mars colonies to work, we need to be able to grow food on the planet itself. But here's where it gets complicated. The soil on Mars, also called regolith, isn't like the soil we have on Earth. It's dry, rocky, and filled with chemicals known as perchlorates, which are toxic to most life as we know it. For Earth's plants to grow, we need soil rich in organic material and nutrients. But Martian soil is missing these essentials. That means growing food on Mars will take more than just planting seeds and hoping for the best. It's a complex challenge that scientists are tackling from multiple angles. One big idea scientists are exploring is creating a closed-loop agricultural system. This means creating a self-sustaining ecosystem where every resource is recycled. Imagine a greenhouse where water, nutrients, and waste are constantly reused. This approach would be essential for a Mars colony, as it reduces dependency on new supplies from Earth and conserves water and nutrients. In a closed-loop system, plants, microorganisms, and even waste play crucial roles. Waste from the colony can be processed into fertilizer, which helps plants grow. Water can be captured, purified, and reused. This type of ecosystem could allow Mars settlers to produce food sustainably without constantly needing Earth's resources. A closed-loop system isn't just practical, it's essential for making Mars a long-term home. Now, let's look more closely at the Martian soil itself. The properties of Martian soil, or regolith, make it a challenging environment for plants. Not only does it lack organic matter, but it also contains perchlorates, which can interfere with plant metabolism. Fortunately, scientists have a promising solution in mind: using microorganisms to enrich the soil and remove these toxic chemicals. Microorganisms, like certain types of bacteria and fungi, play a crucial role in soil health on Earth. They break down organic matter, release nutrients, and support plant roots. Scientists believe we could use similar microbes on Mars to improve soil quality and even break down those toxic perchlorates. For example, some bacteria can actually process minerals in the soil, making nutrients like phosphorus and nitrogen available for plants. Scientists are also studying biomining bacteria, like Aciditibacillus ferroxidans, which could help extract essential nutrients from Martian rock, gradually transforming the soil into something that can support plant life. By using microbial communities adapted to Mars' harsh environment, we could help Mars soil support plant growth in ways that wouldn't be possible with just Earth-based farming techniques. Another critical aspect of Mars agriculture involves the plants themselves. Mars is a harsh environment with high radiation, low atmospheric pressure, and freezing temperatures, which Earth's plants just aren't adapted to. To tackle this, scientists are turning to genetic engineering to create crops that are resilient enough for Mars. Using gene editing tools like CRISPR, researchers are modifying plants to resist radiation, tolerate extreme cold, and survive with fewer nutrients. Imagine a plant that can grow with less sunlight, needs less water, and can survive Mars temperatures. These genetically modified plants could make farming on Mars much more feasible. For example, scientists have been able to modify plants like rice and wheat to be more drought-resistant, and to use available resources more efficiently. By applying similar modifications, we could develop crops capable of thriving on Mars with minimal support. This approach not only makes it possible to grow food, but could also allow us to experiment with new plant varieties, specifically adapted to the Martian landscape. While transforming Martian soil is one approach, scientists are also exploring alternatives to soil-based farming altogether, like hydroponics and aeroponics. In hydroponics, plants grow in a water-based solution, with nutrients completely bypassing the need for soil. Aeroponics takes it a step further by misting plant roots with a nutrient-rich solution. These systems are highly efficient and reduce the amount of water needed, which is critical on Mars where water is scarce. Hydroponics and aeroponics would allow us to grow crops in controlled environments like greenhouses, where we can manage the temperature, humidity, and nutrient levels precisely. This way, we're not relying on Martian soil at all. Instead, we're creating a custom environment for each plant, optimizing growth and conserving resources. Let's talk about one of the biggest challenges on Mars: power and resources. Solar energy will likely be the main power source for Mars settlements. But Mars has intense dust storms that can last for weeks and block sunlight. So, a backup power source, like nuclear energy, might be necessary to keep greenhouses and other systems running smoothly. Water is another limited resource on Mars, so every drop will need to be carefully managed and recycled. Water recycling systems could capture moisture from the Martian atmosphere and purify wastewater from the habitat. By recycling and reusing water within the colony, we can create a steady supply for both drinking and agriculture, maximizing every resource for sustainability. The quest to grow food on Mars is about more than just plants and soil. It's a journey that requires innovation, resilience, and a complete rethinking of agriculture as we know it, from using microorganisms to enrich the soil, to engineering plants that can survive in extreme conditions. Scientists are bringing us closer than ever to making sustainable Martian agriculture a reality. Imagine a future where crops are grown in greenhouses on Mars, providing fresh food for colonists living there. By developing methods to farm on Mars, we're also discovering new ways to improve agriculture here on Earth. Who knows? Maybe Mars-grown crops will one day be a part of our food chain, helping humanity extend its reach into the solar system. If you enjoyed this journey into the science of Mars farming, make sure to like, subscribe, and hit that notification bell for more videos on the future of space exploration and technology. What topic would you like to see us explore next? Let us know in the comments below. Until next time, thanks for watching.